Hello guys and welcome. So first of all, a small caveat: if you don't know any of the tools or theory that I'm gonna be using, well then check out my YouTube channel because there are different lectures on every single tool or theory that I use. And right now, ladies and gentlemen, we're supposed to find all functions that map the real numbers or the real numbers such that they satisfy f of x plus y plus x times y is equal to f of x times f of y for every single x and y that are in the domain, which is the real numbers, as I've already said. And I'm really you see, happy and enthusiastic. Well, good. How to say it in English? I'm thrilled, absolutely thrilled, because this is the first functional equation in this channel. I mean, the first in the free and algebra series. So, well, perfect. Yeah. So, what are we supposed to do here? First of all, maybe let's try and do some basic substitution. Yeah. So maybe let's make our first substitution, the most basic one of all substitution, which is x equal to 0, just as well as y equal to 0 at the same time. So what are we gonna get from this substitution right there? So f of 0 plus 0 is just f of a double 0. So this is f of just a 0. Then 0 times 0 is a 0, not writing down. F of 0 multiplied by f of 0 is f of 0 squared, so f squared of 0, perfect. So well, that's interesting because this actually gives us two solutions, I mean two options for f of 0. Yeah? So f of 0 is the 0, or f of 0 is equal to 1. Yet one of those will be correct. They cannot both be correct because, well, if a function maps one argument to two values, it's not a function anymore. Yeah, so, well, obviously, the problem is that it cannot be 0, in my opinion at least, because, well, if it was 0, then just try and plug in x equal to x and y equal to 0 into the functional equation. What would you get from such a substitution? Let's say x is equal to x, and I would like to say that y will be nothing, y will be 0, and I will make it a temporary, or maybe no, I will make it a substitution 1.2. Yeah, I will erase it in a moment anyway. So f of x plus x times 0 is 0, so not writing it down, is equal to f of x multiplied by f of 0, but f of 0 is supposed to be 0, so it would mean that f of x was equal to 0 at every single value, not only at 0. However, the problem is that it does not satisfy the functional equation. Sorry, my keyboard. It does not satisfy the functional equation we're given because, well, if it did, here we have if f of x was equal to 0 of every single x, here we would have 0, here we also would have 0, so it would basically mean that x times y would be equal to 0, but x and y are not necessarily 0, they can be whatever real number. So it would, for example, allow a real stupid situation, like maybe 1 is equal to 0, which the last time I checked does not make any sense. So, well, I would like to rule out the option for which f of 0 was equal to 0, and so what we're left with is f of 0 equal to 1. I would like actually to create ourselves this beautiful table of facts. Yeah, so facts, and the first fact is gonna be that f of 0 is equal to 1. Perfect. Yeah, lovely. So now that we know that f of 0 is equal to 0, maybe it would be f of 0 is equal to 1, sorry. Maybe it would be really nice to try and, well, use it somehow. Maybe it would be nice to try and get one of those, I mean at least one of those f of x's, f of x plus y's, and f of y's in this original equation to be an f of 0. However, the problem is that I cannot substitute any of the variables being equal to 0 because then I would just, well, unfortunately get rid of those variables that fly free here, and I really want those because, well, actually manipulating those will be the only way for me to get the solution to the functional equation. So I would like to get rid of this stuff right there because I can definitely make this f of x plus y be equal to f of 0 without setting both x and y to 0. That's just by, for example, setting y equal to negative x. Yes, I would like to make a second substitution, so I would like to let x remain fixed and y I would like to set to negative x. So what I would get from here, f of 0, which is 1, so you know what, I will just write 1, and then minus x squared, so that will, I mean x times y will change it to negative x squared. That's all is going to be equal to f of x multiplied by f of y. that's actually interesting because, well, now if I substituted in, yeah, f of y, of a, if I now substitute in, maybe let's call it the third substitution because this one is gonna be like real huge, x equal to 1, yeah, what would I get here? Should have put negative x here, whatever. So what would I get? Well, then I would get 1 minus 1 squared, which is just a 0, 1 minus 1 is 0, so 0 on the left hand side is equal to f of 1 multiplied by f of negative 1. Yeah, so f of 1 right here multiplied by f of negative 1 right there. And so what does it mean, guys? Well, it means that either f of 1 will be equal to 0 or f of negative 1 will be equal to 0, or actually they both can be equal to 0, we have no idea. And we don't need to check it because, well, we can just go on and try and work out the cases and, well, find this term that actually works. So, for the first case, I would like to, well, let's say I would call it case 1, or maybe, yeah, let's get fancy here, blue chalk. So, for the case 1, I would like to assume, or maybe I would like to suppose, that f of 1 will be equal to 0. And so I would like now to use this in order to, guess what, get rid of this stuff right here. It's absolutely perfect because, well, if f of 1 is equal to 0, then I can just take one of those variables, set it equal to 1, this free-flying variable will not disappear because, well, just one of them will disappear and the second one will remain there, multiplied by 1, and this entire right hand side will disappear, so I'm just gonna get f of some single variable equal to some expression in terms of a single variable. Perfect success, because this is exactly what we want to solve this functional equation. So I would like to, I don't know, make, for example, the fourth substitution, which is I would like to let x remain fixed. I would like to set y equal to the beautiful one right there. So letting that happen, we will get f of x plus y will become x plus 1, then plus x times 1, so just an x, will be equal to, well, this is gonna be 0 for sure, so we are gonna get what? We're gonna get that f of x plus 1 will be equal to negative x. And so now let's just shift the argument and just substitute in x minus 1 for x, getting, and then what? Oh, no. Yeah, absolutely. And then what? Getting f of x is equal to negative x minus a 1. Perfect. That's the first thing right there. Am I right? Negative x, yeah. Works, perfect, yeah. So now let me make some space here. I will just erase, whatever, those first substitutions we made. Oh, my camera's about to overheat, whatever, so I have to hurry even more. So, for the case number 2, for the case study number 2, and let me once again grab my fancy blue chalk right there. I would like to assume that f of that negative 1 will be equal to 0, and so I would like to do the same thing as I did before. So I would like to make the fifth substitution of x being equal to x and y being equal to negative 1, and so what I'm getting here is x minus a 1 for that first of x. So f of x minus a 1 minus x, so because, well, this is going to be a negative 1 and multiplied by x, so negative x, is equal to a 0 on the right hand side. I'm sorry, my board, I just have to hit you. It's so thrilling. I love functional equations. So we're gonna get f of x minus 1 minus x is equal to 0. Just shift x, get into the right hand side of this functional equation. We're gonna get f of x minus 1 is equal to x. Now shift the argument, will be f of x is equal to x plus 1, which is perfect. Is exactly what we wanted to get from here. And so, ladies and gentlemen, we are given, that's how it's multiplied. Anyway, we are given two solutions right there. So first of all, f of x is equal to negative x minus a 1, and second one is f of x equal to x plus 1. Yeah, that will be all for today. Hope you enjoyed it, and see you in the next one.